Okay, here we are. Last one. 3-7. We're going to select all the statements that are true about this guy, all right? It says that it has zeros at -5, -2, and 6. Well, let me see. Do I see a +5, a +2, and a -6 in the parentheses? Yes, I do. So that is true. It's saying that the graph is going to look like a quadratic at the 0 that's -2. Here's the 0 that's -2 right here. That's where it comes from. And that 3 is going to make it look like a cubic, not quadratic right there. So C, no, not true. Here we go, end behavior. Okay, let's do B first, because in order to do end behavior, we need to know the degree. So let's figure out the degree first. This says the degree is 5. You guys, the degree is the biggest exponent when you're in standard form. And this is not standard form. In not standard form, we count our x's. Look, this with the 2 right there, this is 2 of them. This with the 3 right there, that's 3 x's. 1, 2, 3. And that is another 1, just 1. Look at that, degree is 1, 2, 3, 4, 5, 6. Not 5, but 6. All right. And now let's do D since we're here. The graph will pass through the x-axis at -2 and 6. Well, if it passes through the x-axis, that means that my multiplicity must be odd. Multiplicity odd, that means you pass through. I did go over this, you guys. If you're wondering, well, what does that mean? I went over this in the 3.6 video. For the explanations and on multiplicity and passing through and bouncing. All right, we went through those on 3.6. Okay, the multiplicity is odd. That means it passes through. So at -2, the multiplicity is odd, so it passes through. And at 6, the multiplicity is 1, which is odd, which means it passes through. True. Okay, E. Okay, let's talk about this. We know the degree is 6, which means it's even. Okay? My function here, look at it. It's positive. All right? There's no negative there. So it's even and it's positive. And if you remember, again, from the 3.6 video where I explained it, all right, even and positive has that kind of end behavior where it's like up and up, okay? So on the left side, I'm going up. On the right side, I'm going up. This is true. And this is saying that on the left, I'm going down, which I'm not, all right? That's if it was an odd degree. They're trying to trick you, make you think it was odd. It's not odd. No. So A, B, D, and E. Okay. Here's a graph of f of x. Select all the equations that could represent this. Okay. So you guys, again, I'm going to look for the easiest stuff first. I see up and up. All right. The fact that it ends up means that I am positive. And the fact that they're both up means that the degree is even. So going through here, I can already eliminate B because B is negative. And then counting my x's, there's 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay. 1, 2, 3, 4. All right. 1, 2, 3, 4, 5, 6. Okay. They didn't give me anything on that one. The rest of these are all even. So now I'm going to have to like get down to business, okay? I'm not getting away with being lazy. I've got a 0 at -4. So that means that I must have an x plus 4 in the equation. And what's more is that my function is going through -4 like a line. Lines have a multiplicity of 1. So my equation must have an x plus 4 to the first power. So not that one. This one, maybe. This one, maybe. That one, no. So I've just eliminated A and E. I'm down to C and D because these guys is x plus 4's had a 2, which would mean that over here it would have to look like a parabola, but it doesn't, so it's not. Okay, I have another x-intercept right here at 1. That means that I should have an x minus 1 in the equation. And given this bounce that's going on and the fact that it looks like a parabola, I expect an x minus 1 with an even degree of at least 2. So it might be 2, it might be 4, it might be 6, all right? But it cannot be 1, 3, 5, all right? Or more than that. All right, here we go. X minus 1 squared. This one is still in the game. X minus 1 squared. This one is still in the game. All right, that didn't help. Let's go look at this one. 2, 3. This is an x minus 3, which I'm looking at it as closely as I can, and it does look like it goes through it like a line. Like that. I don't see it doing like a wiggle. See, going straight through like this, that's a multiplicity of 1. But if it does a little wiggle like that, that's a multiplicity of 3 or higher as long as it's odd. So I see an x minus 3, and I'm thinking it should be to the first power right here. Wait, what? Are these two identical? What is happening here? They are. Oh, it said select all. They're not identical, you guys. This one has a 2, all right? But all my requirements are met with both, all right? If you're wondering, what does this 2 do? The 2 makes a vertical stretch. I'll still go through each of these same exact x-intercepts, behaving the same way. I just might dip more or less, okay, based on the number in the front. But it's not going to change the x-intercepts, and it's not going to change the behavior of the function around those x-intercepts, okay? Which of these could represent this guy? Let's go gather the information we need. Negative. Do you see how it's a negative right after that equal sign? It's negative. It's got a degree of 7. There's 4 x's here and 3 x's here. So degree is 7. A negative odd degree has that kind of end behavior. So up and down. This is down and up. That one's out. Up and down. All right. Up and down. Okay. Up and up. Not okay. So now I'm between B and C. And I'm going to find a key difference between B and C and analyze it there. I notice here at -1, this one is going through. Where here at -1, this one is bouncing. It's not going through. It's hitting the -1 and then coming back up. So let's see what I've got. At -1, ooh, look at this. Look how mean they are. Oh, I love it. I love it. Freaking genius. Look at this. You better know where that -1 x-intercept came from. Not the one with a -1. It came from the one with a +1. And the exponent of that is odd, which means we go through, which means this is B. And oh my God, if I could put this on a test, I love it. Okay, let's keep going. A 5th degree polynomial has a 0 at x equals 4, and it has a multiplicity of 3. It has a 0 at -1 with a multiplicity of 2, which could represent it. All right, let's look at this guy. -4, multiplicity 3. That looks okay. Oh, wait, no. No. They're saying the x is at 4. The 0 is at 4. Sorry, I should be looking at 4. Okay? In the equation, it would be x minus 4 with a 3. However, the x-intercept is at positive 4. So not this one. Not this one. Because again, it's not a 4. This one is at 4. And we're going through. And with a multiplicity of 3, I should be going through. And in a negative 1, I've got a multiplicity of 2, so I should be bouncing. This is it. This is the one. Okay. Here's a graph of f of x. Select all the equations that could represent the function. All right, I see it being down and down. That tells me that it's even and negative. So I'm going to eliminate the positive one. And even, so this one's degree is 4, 4, 4, and 4. Okay, so they didn't give me, the even didn't help. Okay, then I'm noticing that it's got a 0 right here at negative something, which means I should have an x plus something, and it should be squared or at least even. Okay, then over here, I've got a positive something. So I should have an x minus something. And it should be still even. So 2 or at least even. Why? Because we bounced. All right. So we have a bounce and a bounce. So even multiplicities. Okay. Now here's the last thing that might help me narrow it down. This one is further away than this one. So I expect the smaller number here and a larger number there. Or further away, I should call it. All right? Okay, let's go see. Minus 3 with an even power, minus 1. No, one of them needs to be minus and one of them needs to be plus. So that one's out. Do we have more of those? No, that was the only one we got that way. Okay. Now, the one with the plus needs to have a bigger number. The one with the minus needs to have a smaller number. So that works. The one with the plus, bigger number. The one with the minus, smaller number. Okay. The one with the plus, bigger number. The one with the minus, smaller number. Okay. So that was satisfied for all of them. And then lastly, I need all these multiplicities to be even. So even. Oh, wait, what? Yeah. All of these are okay. Yeah, I don't see anything about these that would make this not okay. All right. Yeah. Okay. Spiral review. Write each as a product of 2 factors. What does that mean? That means factor. You guys, I'm not gonna do it. I got videos on this. I've done a million of these. Go watch the old videos. Learn how to do it if you don't already know how. Then come back and try this, please. All right? I could give you the answers. This one's x plus 6, x plus 1. If you just copy it down, you're doing yourself a disservice. Make sure you know how to do this, okay? This one is x plus 5, x minus 2. And this one is x plus, nope, they're both minus. X minus 7, x minus 4. All right, go learn how to factor and come back. All right, and then finding the zeros. Again, factor right here, set it equal to 0, factor solve. All right. Oh, actually, maybe this doesn't factor. Quadratic formula. Solve it. Factor, set it equal to 0, factor and solve. Okay? All right.